Geospatial data collection, module 4. This is a little bit the summary of the training today. It's gonna be well, we're gonna make a quick overview about the GPS unit. It's something that even if most of the countries are moving to CAPI. A GPS is still a tool that we use in the field. When the tablet is, for example, we are running a listing in FSM, and we're gonna have backup paper questionnaires, and with those paper questionnaires, we're gonna provide to the enumerators a GPS in case the tablet, we have a problem, it doesn't work, it gets broken, don't know, whatever. We have a backup, which is the methodology that we were using previously. I don't like to call it the old because it's still valid. Actually, we have here in the region, as far as I know, 3 months ago, we ran a listing in Wallis and Futuna using paper and GPS, 3,000 households. Only 4 households, we were not able to connect them to the GPS. Okay, so it was as reliable as the CAPI system. Okay, if you follow methodology in order to avoid errors, in order to correct, monitor potential typing errors or code entering errors, you can have good quality. Okay, it's true that Wallis and Futuna, we'll see in terms of logistics, is easy. It's only 3,000 households. There are only 2 islands. The internet connection, the agents or officers permanently working on that island. So if we need to make any correction, we had the opportunity of call the enumerator, and 2 weeks later, can you please pass by? So it's a typical context where the enumerators know very well the village. They can locate a household by the name of the head of the household. So it was possible to make many corrections. But at the end, the dataset had a very good quality. Okay, using paper, GPS, manual data entry. So, okay, but it did work. Okay, so this, it's not all. It's just another way to work. It depends. Okay. We're gonna talk about GPS accuracy and precision a little bit more. We are gonna go a little bit in deep, because, well, I think this is important. Sometimes we find situations where the GPS is giving errors in CAPI, and we think, no, the tablet is not working, and it's just a matter of understand a couple of concepts. Okay, point locations, calculate area, and export data either from GPS or from CAPI app into the GIS. So the GPS, okay, we don't. In the title, I wrote use of recreational GPS units, because these GPS units that we have been using the last 10-15 years, the typical yellow Garmin GPS unit, they are recreational units. They are not professional units. Okay, professional units is this equipment, the big antenna that you have the operator like in the same place like 30 seconds, and okay, that provides much better accuracy. But the equipment are much are very expensive, so we cannot provide 200 of those equipment just to have a very good accuracy in the household location. So it's just well, this is enough. It's cost effective, they are cheap, and they do their job very well. Okay, as I was saying the first or the second day, we don't need to build a bridge. We don't need that precision. Okay, we are not lands department. We are just roughly locating household locations. Okay, so they provide an accuracy. They deliver maximum 3 meters accuracy. Okay, 3 to 5. 3 meters. It's when you have optimal conditions. When you let the GPS unit to make all the calculation, which means that you stay like a couple of minutes in the same place without moving, like this. So they are very adapted for field work. This is funny. They are waterproof, okay? And I put in brackets rain, okay? Because, well, I have heard the story like, okay, they say, hey, they are waterproof, and the hour after the people were like, syncing the GPS to test whether they were waterproof or not. And in a bucket, like, what's the point? So actually, I read the other day the specifications, and it's 1 meter. This like 1 meter deep, waterproof. Rain, okay? And even if you have had rain conditions, it's better like to try to protect the device, okay? They use standard AA batteries, and in normal conditions that provides us like 20-25 hours of autonomy, which is very good. It's 3 days working 8 hours a day. If you are out of batteries, they are easy to find in any shop, okay, or everywhere, or you can transport them easily. So you don't need a charger, you don't need the specific batteries. So this is well, quite convenient. And it has a GPS and GLONASS satellite constellation. GPS is the American, the satellite constellation from United States, and GLONASS is the Russian. Now there's another constellation. It's Galileo, and that will improve a little bit the accuracy with the global position systems. We good. Okay, so this is because this has happened to me many times, like either with the GPS unit or with the tablet, that people call me and say, Luis, the GPS of the tablets doesn't work, or the GPS does not work. It's not giving, I download the points into the map, and it's giving me points in the sea. Okay? So what happens? The GPS, it's a calculator machine, okay? So what it does, the GPS, is to get the signal from the satellite, okay? Once they receive the signal from the satellite, the GPS knows which satellites he's contacting with, okay? Because we have different satellites. So we have the Earth here. Okay, so we have the satellites like this, okay? So if we are here with my GPS unit, I will only get signal from this satellite 1, 2, 3, 4. But I never get signal. I won't be able to get signal from the satellite 8 or 7, okay? The problem is that I may have used, in this case, those GPS have been used in Wallis and Futuna for the sensors and for the listing. So they have traveled a lot. So the GPS first needs to know which is the ID of those satellites. Those satellites are going to send to the GPS the ephemeris and the calendar, okay? Which is a table which is saying, okay, the 1st of January of 2018, I'm going to be in this position, okay? This is something that is sending, okay? The GPS calculates its position using the satellite's position. But he needs first to know where the satellites are, okay? So there's information that is retrieving from the satellites. When our GPS has been off for months or for years, okay, when he wakes up, he needs first to say, okay, where am I? And to know where am I, first, which satellites are available? Okay, I'm retrieving the information about which satellites. Now I need to have these huge files that the satellites transmit all the time with a table that is time and position, okay? And with these tables, it's going to be able, with these tables and we'll see the length, okay, of these lines that it calculates because of the difference of time, well, more or less, okay? He make his calculation, okay? But he needs all that information to start providing accurate data, okay? So at the very first moment this morning, when we switch on the GPS or tablets, the tablets that we are going to use in FSM, they were switched off in RMI. They have been switched on here in Numea because Tonga and Winston, they were preparing them. So they are, okay, we are in Numea, and then they're going to be switched off and fly back to the same region, to RMI. But there are different satellites here than, the satellites are different here than in FSM, okay? So the GPS needs time, okay, to start providing accurate, okay? So if now we switch on the GPS, we put the batteries, we hit the field, and we start plotting points, those points are going to be chaos, okay? We will have points, don't know, at 100 kilometers, another points in Wallis and Futuna, you know, because the GPS has not retrieved yet all the information needed to calculate, to estimate its position, okay? So that's why we have this concept of startup. That's what I think it's better explained here. So the GPS needs at least 4 satellites, the almanac, the initial location, time, and ephemeris data. All these data in relation with the GPS position, okay? The satellite's position. So the terms of cold, warm, and hot start, it indicates which is the current situation of the GPS, which part of the data the GPS has available or not. In a cold start, the start that we are going to experience with the GPS units today, it means that the GPS will need to, since it has traveled from Wallis and Futuna up to here, he will need to download, retrieve all that information, calendar, initial position, ephemeris, okay? It's just not the signal, okay? So this is called start. And it happens when GPS has been turning off for a long time, or when the GPS units have traveled long distance, okay? It might happen in Kiribati, it might happen from one island to another in Marshall Island, in Fiji, okay? We take a flight, we move 500 kilometers. That GPS unit, we will need some time to start providing the position with enough accuracy. Okay. Warm start. It means that it has already those tables, those additional data sets, and the initial position, but just need a couple of minutes just to adjust, okay, by receiving signal from the GPS. And hot start, it's when we we go from a household to another, or when we just stop for the lunch break, so we switch off the GPS, we take rest, and we continue later to keep working plotting households. Okay. So to get a fix, to get a point, will take in what seconds? Okay, 20 seconds, 10 seconds. Okay. So let's keep talking about accuracy and precision. Here you have this typical figure, this typical graph explaining what is accurate, what is accuracy, and what is precision. Okay, when we are accurate, it's that we are locating the position. We are properly locating the position. Okay, but these units, they are not precise. Okay, they have these 3 meters. Okay, so we can be having accuracy, but we are not going to get the point, the exactly the place where I'm taking the plot. So, but I think the easiest for me to understand the concept is precise and inaccurate. So we are not getting the right location, but all the points are hitting in the same place or very close to each other. Okay, this is precision. Okay, all the points all together, even if they are in the wrong place. And accurate and precise is like we have the right position and all the points close together. Okay, so there's many factors, okay, that we cannot control. Okay, like the position of the satellites or the satellites available in that moment, atmospheric reflection effects. It is some atmospheric events that sometimes they reflect the GPS signals, and this is something. Or the weather it's very cloudy, so the quality of the signal is very low. So, well, these are factors that we cannot control. Okay, we switch on the GPS unit, and this is what it is. Okay, there's nothing to do with that. But there's other stuff that we can do to improve the accuracy of our position, of our locations. Okay, and on the or maybe it's from another point of view. Okay, we need to do this. Okay, to not to get too many errors, to not to get low quality locations. Okay, because sometimes it's not the problem of the device, it's the problem of the enumerator. Okay, that he's not doing the work properly. Maybe because in the training he didn't understand which are the different steps. Okay, so we have to be very careful explaining the enumerators how this works or how the GPS in tablets works. Okay, so first get a clear view of the sky. Okay, if we are under the canopy, if we are very close to the dwelling, and if we are under a shade, under a roof, okay, inside the building, we won't never get an accurate plot. Okay, keep away from trees, buildings, and other obstacles. So for me, the most visual message is like, if you cannot see the sky, you're not in the right location to get a GPS location. Okay? Okay. If I'm very close to the wall of this building, I'm gathering, like here, I'm gathering reflected signals. So I will probably, if I get this signal, my GPS will estimate that we are here, not here. Okay? And hold the position. This is basic. Okay? We always go with the GPS like if we were in a race. Okay? Like, pa, 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 pa. No. You have to, once you are gonna get a position, you have to wait at least 20-30 seconds. The more time you stay on hold on your position, the more time you hold your position, the better is gonna be the quality of that point. Because when we move, the GPS is calculating and calculating because the signals are different. Okay? But when we hold the position, the GPS is like, okay, it's calculating the same. So the more time we give to the GPS to calculate in the same place, the more is going to be the accuracy of the position. Sorry. Okay? This is valid either for GPS units, well, for recreational, well, I call it GPS units, and the GPS devices integrated in tablets or smartphones. Then there's a slight difference between GPS and tablets. Tablets can improve the quality of the GPS signals using mobile phone data, routers, other ancillary resources rather than additional to the satellites. Okay, so when we have mobile phone antennas close, it's using this to improve the quality of the accuracy. But even if we have this available, for the moment, this is improving. The accuracy provided by tablets will be always worse than the accuracy provided by a recreational unit. Okay, we're talking about 10 to 20 meters, 3 to 5 meters. Okay, and then it's up to us to decide when this is better option or when this is a better option. It's up to you to analyze and to assess and to evaluate which device we want to use. So for the recreational units, quick start. Okay, now let's work with the GPS. If you can, the people who has a GPS unit with you can take this. Okay, so let's put the batteries in. Like this, I'm going through the presentation, and then, well, most of you have used the GPS, so it's going to be fast. Okay, just a refresh, just in case, before we hit the field. So to switch on the to open the batteries, we have this kind of key here. We have to turn to the left and remove the cover. Okay, then we put the batteries and we close again. It's okay? We close, turning to the right. We have here behind the screen, we have the mini USB port connection. This in the new units, the units that have been provided by Garmin, I don't know, like 6-7 years ago. Before, with the old units, there was a specific cable, And it was a pain because if you lose that cable, you could not retrieve data from the GPS. Now it's a standard, thanks God. And if you lose the cable, it's easily, well, you can easily find this mini USB port, okay? So that's good. And then to turn on the GPS unit, we just hold on light button. Okay? Then when we want to navigate through the menu, you have this joystick. Okay? This is something that has improved a lot as well, because it's even if it's not as user-friendly as a tactile screen, well, it's okay. And you can click, okay? So you can navigate through the menus using the joystick, and when you want to select something, you just click on the joystick, okay? And then if we want to go back on the screen, we click on this back. You will see this menu here. So you just use the joystick and you click on this satellite button. Please join your colleagues, and like this you can all take a look on the GPS. So you will have this screen here. Okay? So this is the satellite screen, and this screen provides information about the satellites available. Okay? So here you have I think the white ones are GLONASS, and the black ones are United States constellation. Whatever. Okay, we don't care. We don't really care. So whether it's never mind. Okay. Both are super nice. Okay. They both work. So you see that these codes, the satellite number 2, number 5. So when we have these black or dark gray bars, it means that we are connected to those satellites. Okay. That we are retrieving information for these satellites. So you will see that now, well, from now it's okay. Okay. Then during the coffee break, we will take the GPS out and we will allow them to retrieve all the information needed to start to hit the field afterwards. Okay. So then we're gonna set up our GPS. So here I need that the people who's using the GPS pays attention to these instructions. Okay, I think that they are all well configured because they were used during the listing in Wallis and Futuna, but just in case. Okay, so we are going to go to the setup screen, the one who is surrounded by the red square. Okay, and then we're gonna see this screen. Okay, in setup, we click on the position format menu, and then we are gonna find this. Okay, so this has to be set like I think like this. Okay, so the position format has to be HDD dot like decimal degrees. Okay, this is important because as we were discussing later, the first day I think, if we retrieve the data in degrees, minutes and seconds, I do it like once a year, but every time I lose the Excel sheet that I used to convert from degrees, minutes, seconds into the decimal degrees, and it takes me all the time like 20 minutes just to. So and it's something that I wouldn't like to to do today, actually. So the position format has to look like this. Okay. Okay. Then to what the stuff it's important here. How do we plot point locations? Okay, if you go to the menu, so you click on back, this button here, you go to the main menu. It's just, you will find this this icon with the flag. It's called Mark Waypoint. Okay. When we click on Mark Waypoint, we will see this screen. Okay. Already with the ID of the point and with the coordinates. Okay. Which means, and this is very important, okay, the moment we click on the mark point button, this is important. The moment we click on the mark waypoint button here is the moment where we are capturing the location. It's not when we click on done, okay? It's that the moment. Why I'm trying to highlight this? Because sometimes we have people that they just are walking. Well, I'm going to the household. So to save some time, they mark the waypoint and they start writing the household ID, and then they think that when they are in front of the household, by clicking on done, they gathering, they collecting, okay, the GPS position, and it's before, so they are plotting like 100 meters far from the real position, okay. So it's when we mark waypoint, okay, when we are, boom, getting the fix. So before we click on mark position, we need to think that if we spend like around 30 seconds in my position, allowing the GPS unit to calculate where am I, okay, I do my calculations. Then after 30 seconds, you click, and you probably will get a nice location, okay, or a roughly accurate location. So there's another feature in our GPS. There's another tool which is called area calculation. Okay. Before I go through this area calculation, I'm gonna make a design. So when I'm okay, this is the map, and this is me. Okay, and this is me. Well, these are the satellites. Okay, and this is me with the GPS unit. Okay. What the 3 to 5? You know that in the satellite here, in the satellite screen, you have this GPS, and it's in feet, but it will be in meters. Okay. We will check as well that we are using meters. They coming from Wallis and Futuna. They used to use meters, so it should be fine. So it's indicating us which is the accuracy. Okay. If in this screen I have 3 meters, this means roughly that in a circumference of 3 meters, the plot I'm gonna get from when I put it on my map is one of these points. I can be lucky and it could be boom, okay? But this is the concept of the accuracy, okay? It can be one of these infinite points in my, so the more time I hold the position, okay, so this is the 5 meters, okay? The more time I hold the position, the smaller is this circumference, okay? And the more precise is my location, okay? Then, this is important because for calculating areas, we are doing this, but like if we were on automatic mode, okay? So when we calculate an area, imagine that I have this plot, okay? And I start walking from here with my GPS unit, okay? So the positions that I'm gathering, the positions that I'm collecting, unfortunately, because we are not using a professional device, are not this, okay? That then allow us to calculate the area. The positions I'm gathering, I'm collecting, are sometimes here, inside, sometimes outside, sometimes behind me, sometimes there. So more or less, the perimeter of the area that I'm trying to trace with the GPS, it's like, well, roughly, yeah, it's not. Because and this is 3 meters, more or less, okay? So we will see that later when we plot those calculate or these points that we want, this vertex that we're gonna plot with the GPS and with the tablets, that it's very different, okay? And then there's another element which are the projections. But well, this is something that I think that the main objective today is like hit the field, get some data, put it in the map, and discuss, okay? Because we need to be we need to know which are the limitations of the measurements that we are gathering, okay? When we calculate the area of an agriculture plot, at the very end, we don't need that area for very technical issues. We are not going to calculate, don't know, the number of sheets, okay? Or we are not going to calculate an irrigation system. To do that, we will need proper a topographical survey, okay? We have our GPS and we are trying to assess roughly the size of the agriculture plot, okay? But we are not, with this type of tools, it will be very hard to get a precise and accurate measurement, okay? Just to have this in mind. So the calculate areas, maybe I should have, well, it's easy. It's not very complicated. We go to the menu and you will see this tool called area calculation. Then we click on start and we start walk around the area we want to calculate, okay? But I put in brackets, slowly, okay? If we walk very fast, the GPS, it won't have time to calculate. So if we run around the area, the perimeter of the trace we're gonna get is gonna be, okay, not very good. So same approach, okay? The more time, the slower we walk, the better will be the area calculation, okay? Then select change units if you want to change the units to acres, to hectares, for example. You will see that in your paper questionnaire, they are asking you to enter the area in square meters. So we will select square meters in the menu when we want to calculate the area, okay? So this is something that we're gonna go later. Well, to extract data, I will go through this slide later when we are going to extract data. We did it this the first day when we extracted points from a GPX files, but now it's gonna be for real. It's not gonna be a fake GPX. Okay? You're gonna connect your GPS units to the laptop, and you're gonna bring that into the into QGIS. CAPI, computer assisted interview. Okay? Okay, we're good. So, tablets. Okay, so summary. Just a few slides of introduction to CAPI. We're gonna talk mostly about the survey solution, because it's the app that we are working with, and actually I'm gonna talk a little bit about the others, but I don't have much experience. Maybe Anthony, you have experience with CS Pro, so you can give us a quick review about CAPI CS Pro, and like this you have all the information. And okay, and then I will show you, and we will play a little bit with the questionnaire, okay? In order to have a clear idea about how the questionnaire works before we hit the field. So now, before I start with CAPI, we know how to plot a GPS point with this. We know how to calculate area, okay? Do you all, because this is GPS plus PAPI, have you taken a look to the paper questionnaire? It's just a table, it's very easy. Take a look. If you don't understand, if there's any question, just we can discuss this before the coffee break. Okay, so computer-assisted personal interviews, face-to-face interview method, where we are using tablets to enter data, okay? And to record the answers during the interview. Advantage, we have validation rules that can prevent us to enter wrong data in the questionnaire. So, for example, typical one is then you ask how many female live in the household. You enter 2. How many male? 3. How many? Which is the household size? And if you enter 6, you will have an error message saying, okay, but you have put 2 male, 3 females. It cannot be 6. Okay? This is something that improves the quality from the beginning. Before, with PAPI, we were entering that data. If the enumerator made the calculation wrongly, it's something that we need to clean during the data processing or during the data cleaning. Okay? Now this is happening while we are entering data into the questionnaire. Data is in an electronic format, so there's no data entry process, which means that we save time and money, okay? And that we can publish, we can disseminate data in a shorter time, okay? Skips. There are validation rules that can be programmed to make the questionnaire more efficient and accurate. When you have a paper questionnaire, you have your, for example, your disability module, okay? In CAPI, if there is no person with disability in that household, that module of the questionnaire won't be available. So you don't have to pass through the questionnaire. This module will be disabled. Okay. The same for don't know how many. Well, the example was good. Or for example, or are you is this household involved in agriculture? No. So all the question about crops, about your activity is for self-consumption or for commercialization, okay? All those questions, they are not available. So we don't have to, and we cannot enter information in there by accident, okay? So it makes the questionnaire faster, more efficient, and it's easier for the enumerator, okay? There's monitoring features. So, for example, the software can record start and end time and GPS location. So supervisors can check whether this interview is, for example, is real or not. If we see that the questionnaire starts at 12 o'clock and in 3 minutes the guy finished, it means that he was like, and okay, another one. So if we are paying by questionnaire completed, for example, we can prevent that the enumerators just, okay, the household is, for example, the household is vacant, but if he says, okay, well, who cares? I know the guy, so I'm going to answer for him. And I got my US dollar because I got a complete questionnaire. But then the supervisor, you can run a script saying, okay, which is the time when the questionnaire starts, which is the time when the questionnaire ends, and if it's less than 3 minutes, we have a problem, okay? The hardware, tablets, we use like medium quality or medium capacity tablets. Okay, you don't need iPads, you don't need $1,000 tablets. We usually use Samsung, Lenovo, Acer. Well, the model we have used the most are Samsung. Was the first ones we acquired were Samsung. They work well, and we decided not to change because our trainers, we are used as well to the configuration menus. Well, they are very similar to other models, but they work well. And but minimum requirements, okay? Wi-Fi and cellular connectivity. If you know that there's tablets with. I have a tablet that it has no entry for a SIM card because I never use it as a cell phone, okay? Our tablet has to be prepared to work with 3G, 4G, 5G SIM cards, okay? Front and back cameras. Well, front camera, it's more than enough, but just in case if you want to make a selfie with, because it's super funny that, no? We have when you are supervising listings, for example, sometimes the supervisors, rather than doing the photo of the front of the dwelling, they are doing like, yeah, sometimes you find like photos like, wow, that's great. Well, the photo is something that at the very end of the questionnaire we delete. But for surveys, for example, this is another data. This is another item that helps us to locate the household. When you make a survey, even if you have less accuracy, you have the name of the head of the household and you have a photo, okay, of the dwelling. So here in the Pacific, in rural context, in rural environment, this is very useful, okay, when we want to locate a household. Okay, even if we have the face of the enumerator, like yeah, but well, it's quite useful. So front and back cameras, up to date Android operating system. Okay, 4 years old tablet. Unfortunately, we will need to update the operating system. Well, so we have to have this in mind. If we want to use old tablets, we will need to update, or we will need probably to install a new Android operating system, okay? Because all those CAPI softwares, they permanently update, and they try to be compatible with the latest Android systems, versions. Size, it depends on the complexity of the questionnaire. For a census, for a listing, this type of site, a little bit bigger, they are okay. It's true that for complex questionnaires, where we have big tables, where we have long lists, okay, to select, for example, labor force, when you are collecting the activity, etc. Maybe a bigger one, or tablets where the interviewer, the person you are interviewing, needs to work or design or do something bigger. But at the same time, the bigger is the tablet, the less battery autonomy it has, more or less. The bigger is the screen, the more battery consumption we have. So we have to try to, and it's heavier, it's more complicated for the, This is good, you can put it in your pocket, so they are well. We have to find the right model to cover our needs. And 1 GB of memory, more if the server is particularly complex and we have multiple questionnaires, so we need memory enough to make the navigation through the questionnaires fast and reactive, okay? And internal storage, okay? Because if you are going to capture many photos, sometimes we capture we scan the ID card, sometimes we make photos of the family members, sometimes we make photos of the agriculture plot from different places, sometimes we scan code bars, okay? So the more complex is the questionnaire, the more information we are collecting, images, voice recordings, etc., the more memory we need to put in place, okay? But you can do this by purchasing SD cards, okay? To expand the memory. Then, GPS. The GPS is pretty poor. If one day we decide to keep working with CAPI and we definitely need to improve the GPS accuracy, this is possible. There are GPS devices that can be connected via Bluetooth with the tablet, and then survey solution, we know that they are compatible. So once you set up the tablet, you can say, okay, I disable the built-in, the integrated GPS antenna, and the device which is going to receive the GPS location is an external device that is connected via Bluetooth. This consumes more battery because you have your Bluetooth activated the whole day, but you can get the same precision as the recreational units. From the same precision with devices that are not very expensive, and I saw in some of the providers, and I saw that you can get even 60 centimeters or 1 centimeter accuracy, but we are talking about $6,000–7,000 US for those. Well, this is the one that provides 3 to 5. But they are very expensive, and at which point it is better to just rent a more professional, hire a topographic surveyor company to make some of the measurements rather than using the tablet. Well, it's available, and sometimes we might find that this is the need that we have to cover. So, okay, but just to let you know that if we still want to use tablets, GPS accuracy can be improved, okay? And if you want very under meter, sub-meter accuracy, it's possible to still use in your tablet, but you have to pay it, okay? Then CAPI, Survey Solution app, okay? Thus, when we started to plan when we started planning to work with CAPI, there was a reviewing process. This is 3-4 years ago, and we tested different solutions. We assessed different software available. We assessed ArcGIS 123 survey, and another one from ArcGIS. CS Pro at that time, I think that it was not very developed, so there was not many softwares to choose, but there were still. So at the end, we decided to go with Survey Solution for these reasons. Okay, it's free software and has been developed by the World Bank. We don't need much. We don't need huge or advanced skills in programming. Okay, there's a little bit of programming language when we design the questionnaires, but it's something easy to handle, and there's lots of examples and documentation and other questionnaires that you can copy and paste and look at to see how did they structure the different questions. The data can be monitored. The supervisor can monitor data in real time and has powerful management tools like built-in reports, data quality control. So there's a map report into the server where we can take a look what's going on in the field, etc. I put here the link if you want further information. As I was telling, this is not a CAPI. This is not a module where we are going to explain in detail what a CAPI is, but okay. So other CAPI solutions available: Survey 123 for a GIS, Fulcrum. I will tell you. Well, Fulcrum, it's a private API, CAPI solution. And there was a just to give you a quick review or an example where Fulcrum has been used in the Pacific. I was contacted by a consultant, Australian consultant working for I think it was UNDP, in a project of improve facilities in South Tarawa. Okay, so they were trying to collect information about water tanks. Okay, so they needed a CAPI solution, and they needed to identify the household by the roof in order to estimate as well which is their captation or rainwater captation capacity, to estimate. The more surface you have in the roof, the more water you can collect from the rain. Okay, so what they did is more complex, and but it's I think it's a good example. What they did is just they use a drone to get to make a photo of to cover with images the entire South Tarawa, and then they digitize the roof of each of the dwellings. Okay, so there was a shape file with the roofs. Okay, so the enumerators were going dwelling by dwelling, and they were filling some information about water. About, do you have a tank? Yes, no. Do you have access to tap water? Yes, no. etc., etc. And they were locating the household using those roof layers. So they were selecting which roof to which dwelling belongs the roof. But it was, rather than using a GPS, they had a satellite image background with a polygon layer with the digitized roofs. And you could select, okay, this square here is that household. This square here, and this is something that Fulcrum can do. He has more GIS capabilities, okay? To say that it's $20 a month to have around $20–30 a month per tablet. So if you're gonna, well, for a small survey, so these are the solutions that we can explore that maybe you have to pay for, but for small surveys or for, okay, if you are looking for more interaction with spatial information, maybe Fulcrum or maybe others can be a proper solution. Yeah. We use survey solutions, but it doesn't mean that is the only CAPI software available or is best for any of the situations we can find. Okay. So I'm gonna just make a quick review about how a survey solution questionnaire works, or which are the main features we can find, or when we start working with a questionnaire in a survey solutions environment. So main features, okay, used for data collection in the field. We have built-in validation checks, these error checks that you have built in the questionnaire that prevent you to introduce or to enter wrong data in the questionnaire. And color code. This is important when we will be in the field, just to know what these three colors means. Okay. A blue, when our screen is in blue, it means that we have started the work, we have started a questionnaire, but there's no errors yet, but it hasn't been complete, okay? When it's red, it means that we have entered something wrong, that some of these validation checks have been activated, okay? So if our screen is in red, there's something that we have to review, okay? And if it's green, it means that our questionnaire has been finished and it's clean, okay? So we can send it to the supervisor. To say that we can always send to our supervisors or to the server, even if they have errors, we can send them. Even if they have not been completed, we can send them. It's not it's gonna be a headache for your supervisors, but this is what we call soft validation. Okay, even if it's if there's a validation saying, okay, here in that question, this data, this information that you have entered doesn't look good, you can say, okay, complete, and send to the upload it into the server. For example, you used to put a rule that the household size cannot be more than 50. Okay, just in case the enumerator type a 0 at the end, so it's 5, and then by accident type 0 and it's 30. Okay, but if you type 50, because there's indeed 50 people who slept last night in that household, then you will have the error on the validation check. But since this information is true, you can send it, okay? And you can add a comment saying, okay, they are 54 because there was a marriage and they were all together sleeping in the dwelling, okay? So, and you inform your supervisor the reason why this data doesn't look, has not been validated by the validation check. Then it shows you the data summary. So at the end of the questionnaire, you have how many questions are not completed. So you will have, if you have some question that has not been completed, they will your questionnaire will appear in blue. Okay, and then you can navigate back to the questions that you have not completed, complete them, your questionnaire becomes green, and then you can send them. The same with the errors, okay? So, and they complete the questions. So, this is very important. When we need, in which situations do we need internet connections, and in which situations we don't, okay? So, for GPS, for geographic questions that you will see that you have maps appearing there, we do not need internet connection. We only need GPS connection when we make a first login, because we need the tablet to download the questionnaire or the information, and when we are transmitting information to the server, when we are what it's called synchronizing, okay? During the synchronization process, we are going to send our completed interviews to the server, and we are going to receive maybe questionnaires, interviews that have been refused, okay? Because there was some error, there were some inconsistencies, our supervisors had checked the questionnaire, there's something wrong, send back the questionnaire to us with some message. Can you please repeat the GPS question? The household location appears on the sea. Okay, so you will receive a message. Can you please go back to the dwelling and repeat the GPS question? That photo, it is not very good. Or you have entered that the household is vacant, and I see a car, a motorbike, the windows open, and the clothes drying. So that whole household cannot be vacant. Okay, so please pass by again and do your job. So we send, so we can control. Okay, if we have a enumerator that wants to finish his EA fast, and we start seeing that there's 5 vacant households in a row, and the photos does not do not seem that are photos of a vacant household, then we can control that. Okay. So is it clear? For when we are going to hit the field, I want you to disable the Wi-Fi from your tablet. Like this, we can see that we don't need internet connection for GPS and for the mapping questions, okay? For nothing, okay? Our tablets can work offline and can save the questionnaire and can have those validation rules available. Everything is in our table. We don't need internet connection for that, okay? So let's take a look to the CAPI questionnaire. So what I need you to do now, please, if you can switch on your tablets. So, sorry, the password. So you will, by default, when you log in into, well, when you access to Interviewer app, so you have to go to this, you have to click on this icon. It might be in the first screen, or it might be in the applications screen. So are you switching on the tablets? Are they working? Okay. There's no pattern to unblock the screen, so it just slide the, okay, just, okay, and if you don't find that icon on the main screen, you can find it in the app screen. Okay, so the passwords are easy. Are SDD, QGIS in uppercase, okay, and then I and T and the number, okay. If your username is INT1, you will write SDD QGIS INT1, okay. On the back of your tablet, I wrote the number of the. No, it's one. No, it's I2, I3, I. But I wrote I, and it's not the one. Eh? The I1 is mine, so you cannot have the I1. It's impossible. So, did you manage to log in? So once you have logged, so remember, if the username is INT7, then you write INT7, and okay. I wasn't sure whether I was allowed to have the same password for all of the interviewers, so I didn't take the risk. It's already on. Can you see this, the screen? All of you? Yep. Sorry? It's uppercase and then lowercase. And then the number. SDD QGIS is uppercase, INT lowercase. What is called the dashboard, okay? So in the dashboard, we will see this start new interview. We are in census mode, so we can create as many interviews we want, okay? If we are in survey mode, the supervisor will send us assignments, and it will be limited, okay? Go to that household and fill the questionnaire. So we click on, if you can follow me, we click on Start New Interview, okay? We get this screen here, and we click on Cover. And then we have 3 sections, okay? So these are the sections that we are going to go through. Well, in reality, it's 2 sections, and then the last one, it's complete, is the review, where we have the summary providing information about which are the questions that has been correctly completed, if we have errors in the questions, okay? So, and once we finish, for example, so you see now that all my sections are in blue, okay? If I go through my first section, location and building type, I fill all the information. Once everything is okay, you will see that my location and building type is going to become green, okay? Then I go to the geographic and information photo, and I made a mistake in the way I entered the data. I don't get enough accuracy for the GPS. There's an option in Survey Solution that prevent points with less than 30 meters estimated accuracy. Okay, so if we don't hold the position, if we are taking the point like while we are walking, okay, we will have an error message saying, okay, please repeat the GPS question and follow the instructions and hold your position and please try to get less than 30 meters. Okay. So then, if we manage to correct the problem here, we go to the complete screen. Everything turns in green. All the dashboard, the banners, everything. So we can click, and we have here the summary. We have answered 6 questions. We have not complete questions. We have no errors. You can type a note to the supervisor. Okay, this house was vacant. Don't know, whatever. And for example, the head of the household refused to answer the question, or refused to answer this question. So, and like this, we can communicate with the supervisor if we had any issue. And then we can complete it, but we can reopen it. Oh, then you remember. Don't know. Okay, you can reopen it, make some corrections, etc. All the the person you have interviewed says, okay, I answered something wrong, whatever. Okay, and then once everything is green, we click complete, and then we can click on this button here, the synchronization, that you wanna find it on the top left, top right corner. Okay, then we click, and to do the synchronization, we need internet connection. So if we don't have connectivity, we will have a message saying impossible to connect. Please check your internet connection, etc., etc. And then just a quick review about the new feature that has been recently added into Sabe Solution, the maps. So if you go to the menu, to the settings menu, the one with the 3 dots in the top right corner, please click there, because I need you to check whether we have the maps available or not. And then when you click on maps, you see that which maps are available in your tablet, because those maps have been downloaded with the questionnaire. So they are offline maps. They are georeferenced image that are stored in your questionnaire. Okay? Then we can go back to dashboard. If we click again in the 3 dots settings menu. Okay, for the moment we don't have internet connection. It's SDD QGIS INT7. Okay, so we can go to settings, and this is something that I was mentioning right now. We can set the GPS Receive Timeout. Okay, the number of seconds that we wait to get the coordinates. Okay, so, and the desired accuracy of the GPS questions. From the questionnaire designer, we can set a limit. Okay, we can set a threshold for the accuracy. Say, okay, points with less than 30 meters accuracy, we refuse them. We get that message. We still can send that questionnaire. Okay, we are not blocked. We are not restricted to send that questionnaire, but the same. Okay, I want to have accuracy. I don't want to get a fix if the accuracy is less than 30 meters. And this is something that we can as well. This is something that we force the tablet to not to make any fix until the estimated accuracy is less than 30 meters. Okay? So when we are preparing the tablet for the data collection, we will have to set this setting in each of the tablets. Now let's take a. Now what I want you to do is just to take a look in the questionnaire. Go through the different. I'm here in the one in. So here I'm gonna test the same questionnaire. I won't have the map, the Polygon question available, but it's somehow the same as you're gonna be able to look to see in your questionnaires. Okay, so for example, now I go to location and building type. You have all of the teams have a set of 6 maps. So the enumeration maps in the plastic folder. So when you're going to be hitting the field, so you will have the information to fill this. Okay, so I'm at SPC headquarters. IRD is that one, and land annex is the small piece of the space just on that side of the headquarters. So you just check the maps, and if you want to take a plot in each of the districts, okay, this is so I delineate fake districts with 2 enumeration areas in each district, just to make this a little bit funnier, and and try to be close to the enumerator reality, maybe even if it's a basic exercise, but I thought that it would be a good idea. So I imagine that our first plot is going to be SPC. You can fill all the questionnaires you want. Okay, don't be shy. Just play with the questionnaire. Send stuff. We will later on clean the questionnaires with. Okay, so now I'm gonna go to, for example, I'm gonna fill this SPC. Then I click to the answer. I have, instead, rather than having all the EAs available, I only have the EAs in my district. This is something that we can code, and it makes the enumerator's life easier, okay, and prevent potential errors. I only able to enter the EAs within the district, okay? So there's no. So 102 takes a little while in my laptop, sorry. Come on. Okay, so now what type of a survey is this? It's household or agriculture, okay? So I'm gonna go first to the household listing, which is the most the basic one, okay, and then I can go to geographic information, okay. Depending on which option we choose, we will have different geographic questions. So I invite you to, when we are hitting the field, we select both options, okay. The household is easier, so but don't come back with only household listings, okay, because so is the household occupied? Yes. How many people? Just basic one, okay? And then you will be asked to record the GPS point and make a photo of the fake. You can make a photo of one. You can make a selfie, make a photo of one building, of one car, whatever, okay? We are just pretending that we are. And then once it's complete, okay, what if I open a new one and I choose that I want to make an agriculture plot. Please pay attention on the screen, okay? So I have one first question that is record the area drawing a polygon on the map. Can you please click on this question? So in the first section, location and building type, I'm going to select agriculture survey. If we don't select agriculture plot, this question won't be enabled. Okay, so if you click in the polygon question, record plot area drawing a polygon in the map, do we see a satellite image of the SPC headquarters on our tablet? You have to go to agriculture plot. In the first section, here, first section, in the question 1A, what kind of survey is this? Is agriculture plot. If we don't do this, the polygon question won't be enabled. Clicking by pressing on the different points of the polygon that we want to delineate, we're just going to delineate the polygon. Make a trial. It's just a matter of, and don't be shy, don't be worry about if you are going to do it wrongly, just draw a polygon, okay? I just want you to be familiar with this before we hit the field. So I think that what we can do now is we stop here. We're going to take our GPS units and we're going to take our tablets, okay, outside while we are having a coffee to let them take some fresh air and take a good satellite signal. We have a coffee. We come back to the room. We finish with this. We go with this overview of the questionnaire, and then we hit the field for 30 minutes. Okay? Did you take your GPS units out? Okay. Then it doesn't matter if they haven't woke up yet. In case we have discrepancies or points that are very far or they are not accurate, we already know that we haven't waited enough time. Okay, so for the future, when you start activities, when you start trainings, we usually have this problem. You make the test, or you make the first experience with the enumerators close to the building where you are undertaking the training, and half of them the GPS question doesn't work. I cannot get accuracy. I cannot get accuracy. It's just a matter of leave the tablet, turn on, okay? Because if we turn it off, it's not going to retrieve anything from the satellites. Turn on, leave the tablet, open sky outside, okay, and wait 15-20 minutes, and this will be fixed itself, okay? So now I'm going to here location and building type. Imagine that I don't feel because I forgot the so it's incomplete. Yeah, you see that here is not green, it's blue because I didn't enter the district or the year code, okay, or the name of the head of the household. Okay, it remains blue. I'm gonna show you the other questions. Okay, now we have taking a look to the map question. Just to let you know, I only put polygon. Is it possible to set a question with point or line? Not all together, okay? Either polygon or points or line, okay? So for example, for agricultural sensors that we were discussing yesterday, you can now, with this type of questions, go to the household, ask the head of the household, are you involved in agriculture? Yes, okay? And you don't need to walk with him to locate where the farm is. You just can open this question with the map and ask him, okay, where is your farm? Or you can do it by crops, okay? You can open each crop. It's gonna have a location question. You can sit down with him on the table and say, okay, where do you have the corn field? Where do you have the copra field? Where do you have the pigs? Where do you have the chickens? Okay? So one of the questions that we have, number of animals, for example, for auto-consumption or for selling purposes, and then we can have a specific question of the geographic location for each of the livestock items or for each of the crops items. okay, which is kind of a huge advance, okay? It's kind of a huge improvement, and I just now you know this is available for next surveys, for next agriculture sensors, for other stats activities, data collection activities. Take this in mind, please, and if you want to set up something like this, please let us know, and we will try. Well, we will help you. If the well, for the moment it's demo, but I think in a couple of months it will be available for real data collection activities. Okay, and at the same time, it's I talked with the guys from Survey Solution, and they are very interested on your feedback, not mine. Okay, on your feedback. Okay, so I will try. We will try to have a discussion afterwards, and try to get as much as so. Because the more feedback, useful feedback we provide to these guys, the better is gonna be the app, and the more close to our needs they are going to be. Okay, because they are developing stuff, but sometimes they can be a bit lost. So if we get information from the final users of this application that they are developing, and maybe they haven't thought in some of your needs, so this is something that they will take into account if we provide them feedback. Okay, so there's another way to, well, here I have added other ways to collect data, areas, okay, to calculate areas. So we have, here the question is, please enter the area calculated with the GPS for this point. So in this case we are using GPS plus CAPI, so we are collecting the area with the calculate area of the GPS, and we just type the area on that question. So I just, it's 450 square meters. And then 450 what? And then we select acre, hectare, square meters, others. Smart, huh? Because sometimes when we have paper questionnaires, sometimes we don't know. We have people entering hectares, but it's written on the column square meters, so they are entering the wrong data. So we are preventing potential errors. So it's square meters, for example. Or the guy doesn't know how to change the units of the GPS. It's quite easy in the tool, but for him it's complicated. So we give them the option of, and then this is the first. So we use the GPS. Second one. Well, the last one. So we have done we have estimated the area drawing on an offline map. Remember, offline. It's already in your tablet. You don't need internet connection to have access to the map. Okay. Second one, we have entered the area calculated with the GPS, and the third one, it's a little bit more complicated. It's like a kind of a walk around. Okay. What are we going to do is to create a group of points. Okay. But we need to tell them. To tell the questioner how many plots are we going to gather, how many points are we going to collect. For example, we are going to go to I will ask you to measure or to estimate to calculate the area of the tennis courts. You will see in the maps that there are a couple of tennis courts. I think it's the easiest thing, okay? And you will see in the maps that there are in the annex land, there's a parcel, there's a plot that makes something like this. Okay? So the way we work with this approach is that we are going to take each of the GPS locations. Well, we are going to take the locations of each of the vertex, okay? But we need to tell to the questionnaire first how many points are we going to gather. So if I have a shape like this, I first oversee or foresee how many points I'm gonna take. So 1, 2, 3, 4, 5, okay, 6. So I type here, okay, I want 6 points. And then I will have 6 GPS questions displayed. If the internet connection, because this is online, okay, you can try in tablet. So imagine that you want to measure a tennis court. So you say, okay, I have 4 corners, so I'm gonna use 4 GPS points to delineate the shape of the land plot. Okay, so I get 4 GPS points, so I will get to my first vertex, to my first corner, and click on the GPS. Then I walk to the next corner and click on the second GPS. So what I'm doing is like if I was using a GPS, like plotting each point that delineates the land plot shape. This is a bit tricky. It's going to be a little bit more complex because we are going to need to convert those points into polygons in QGIS environment. And, well, it's a bit challenging, okay? Well, it's easy, but it requires a little bit of manipulation in Excel, okay?
So what do we do?
So now I'm trying. Let's try.
Sure.
So then I say, oh no, I need rather than 6, I need 8. I don't know because I haven't tested. It's a good question. I haven't tested if we lose these GPS points that we have already collected.
You haven't entered 8.
Yes. So I'm gonna do it here. Number of plots, because it's faster. Okay. You can try in your tablet. Yes, it does it. So now it has created 2 additional points and saved the points that you have gathered. So imagine that you are walking like this. You say, okay, I need 20 points. I start walking and I get to my 20 points here. So you go back to the roster and I say, okay, let's add 15 more. And then, but take into account that this is a very time-consuming, you will see in the field. So you will tend to simplify the shape. And this is not made to calculate area. So it's just to give a rough, or it's just, I think here, for me, it's not that tool it's not the right tool to calculate area. Okay? It's a tool to delineate polygons, to delineate the location of the different crops. Because it's not a very nice, all of these, you will see maybe for big surfaces, you will see that we are going to get very different results from the different systems, okay, from the different approach. Now, in the way the question is already configured, I cannot change anything, okay, because I would need to. I can, for example, what I was saying before, the same way I can create a roster of GPS points, I can create a roster of polygon questions. So say, how many land plots do you have? 4. And I will replace these GPS questions by map point question that they can just press where the land is, or polygon delineation, like, or when we work with lines, which road do you use to get your land plot? So we can, you can say, okay, how many crops do you have? 5. And then you can have 5 map questions, and the guy can delineate the land plot. So you can, but it's either polygon or line or point, but you cannot draw polygons and points same time, okay? For the moment, I don't know it in further stages of this app, we will be able, but for the moment it's like this. And then when you download your questionnaire, you get I have to check because I prepared this 1 week ago. You get a polygon, okay? You get the coordinates for your polygon.
After creating the polygon, still in the just to see how many points you already locked for that.
For in the polygon question or in this?
For the polygon, asking the question of how many points.
Actually, you have to draw each of the. At the same time, you count them. But you don't care because when you download that data, you are not downloading points. You are downloading a polygon. Before we hit the field, I would like you to spend maybe 5 minutes going question by question, making some tests, okay? Taking a look to the maps, taking a look to the paper questionnaire. So what I want you to collect is that imagine we're going to pretend that we are running a data collection activity using GPS and paper and using CAPI, okay? So take a look to the, so you don't need to, okay, here you don't need to complicate your life much, you don't need to fulfill everything. I just wanted to give you a paper, a basic paper questionnaire, just to, district, EA, household ID, to feel the difference between both systems, okay? And then you have the maps. Maybe we can assign a team to each of the EAs, or you can select one EA. It would be interesting that we don't know. We have all the teams working here at SPC headquarters. We can go to the other side of the fence. To open that door, the code is 9720. Okay, there's a door with a lock. The code is 9720. And to get the other place, I think that you can open the fence. Maybe we can stay here at SPC at IRD, so the districts 1 and 2, and just pretend that you are collecting a few households using GPS plus PAPI or CAPI, so selecting the household question, and as well making at least three land plots. So you can take the tennis court. There's a palm field there that looks good. You know, some places where we have open view, okay, open sky, like this, the signal is not gonna be affected by the canopy. And then, so we are not going to spend much outside. So it will be a matter of 30 minutes, because I think the interesting thing here, well, we're going to have 5 teams. If you collect 3 land plots each team, we're going to have 15 plots. It's more than enough, okay? I want that each team process their own data, okay? But the interesting thing here is to see the differences to plot what do we have in the to plot the different devices and compare, okay? And remember, when we calculate the area of one land plot, we have to do it using the GPS, the Polygon question, and the Rooster GPS, okay? So we do the same plot with the 3 methods. Like this, we are going to be able to compare the 3 methods. Then we come back. We will connect the tablets to internet, and we will synchronize and send the questionnaires into the server. Okay? First of all, we're going to retrieve the data from the GPS, okay? So we have to, well, we already connected, so we have to go to the GPX. So it's plug and play. We don't need any software. Okay, here we are. So we go to Garmin, then GPX. Okay, and what you can do, simply copy the folder and paste it. Maybe in folder in module full. Okay. So here in GPX, well, I have another registries from 17th of April. 12th November. So I'm gonna just select the GPX file from the 22nd of November. And as I explained on Monday in the first module, we just need to drag the waypoints file. So let's into the QGIS interface. So here, what we are going to select, okay, is the waypoints and track points. Or maybe we can. Yes. So let's see how does it look like. Because the track points no, it's not the track point, sorry, it's the tracks. Well, you know what? At this stage we're going to select everything, and then we check. So you select all, click OK. Okay. Okay. Have you, so we are, for the waypoints that we are extracting, sorry, is the points that we have gathered in when we were marking points, mark waypoints. So for this case, waypoints 22 November, we just select waypoints, okay? But for the tracks that we have draw in the field with the GPS units, when we were using the calculate area tool, these areas, if you have saved those areas, when you know at the end of the calculate area, do you want to save the track? Have you saved the tracks? Well, I did. So I call it track cocoa, okay? Because I was in the palm trees, in the coconut trees, palm trees field over this one, okay? This is the area where we have been working on with the GPS. So I just take it, drag it into the map canvas. And then I think if you select waypoints, let's select all. Okay, that's good. Okay, this is the path that we have been following when we were calculating the area with the GPS unit. Okay, so this is the dots, the points that okay, this is nothing. So the road points, we can remove them because I always forget what is what. Okay, so I always like drag everything into the canvas and then I just filter what's the stuff I need. So this is nothing, roots. Okay, so we keep the points, maybe if you want. And the line. Okay, we keep more the line, okay? We check the track to see if it's only one, okay? It's only one feature. Okay, so we have this. Okay, this is more or less the path that we have followed when we were measuring the area. It's a line, okay? We have already calculated the area. It's gonna be enough. We don't need to, at this stage, we don't need to convert it into a polygon. We could afterwards, if you want, I can show you. But it's gonna be useful to help us to assess the difference between the different methods. Okay? This is what we got from the GPS. Okay? So and you can do the same. You're gonna import one of the tracks and import the household locations. When we import the household locations, we only need to select waypoint, and here we are. So in red, I'm going to draw, or I'm going to in red, it's going to be the outputs we gather from the field, okay? And if you want, I can call it, I'm going to rename, it's going to be GPS households, and this is going to be, we're going to rename it, and we're going to call it GPS areas, okay? Great. So this is what we got from the GPS. Have you been? It's okay to retrieve the data from the GPS? So can you, well, I'm going to increase a little bit this because we don't see much in, okay. So you can see this is the path we, well, we design by using the calculate areas a tool in the GPS, okay? And as well, we got 2 points. The points, the household location of the farmer, and here another household location, okay? All of you have your GPS areas and your GPS household locations, okay? So what I have shared with you is the data that I have downloaded from the survey solution server, okay? We have synchronized our tablet with the server. We have uploaded the data that we have collected into the server, and then I could have, well, I'm going to show you a little bit what I've done. For example, here we have a map report, okay? Here I'm showing the plots that you have been taking. So this is interviewer 3, okay? This is interviewer 3 as well, before they got, in the European, no, this is the one we, okay? This is, for example, interviewer 6, okay? This is interviewer 7, okay? We have the different locations, okay, for households. Then we have the GPS plot, okay? The points that you have been gathering when we were doing the rooster, the group of GPS points. It's a pity. Well, here in the report we cannot. Oh yes. Okay. So for example, these are here. You have some of your points, and we see already that it's the way. Well, a GPS unit used in tablets is not very good delineating polygons. Okay, that system that we were using, like group of GPS, it's a bit coarse, okay? Or maybe we need to create a higher number of points, okay? But since our accuracy is 20 meters, it's too coarse if we want to delineate, because now if we join, for example, this is the plot that the agricultural area that we have plot our team, and you see this point, it was supposed to be here, and this point should be here in order to delineate the 4-5 corners of the land plot. Okay, if we take a look, for example, the team, Arnold's team. Well, we don't know. Which team are you, Arnold? Interview 2? Yeah. So your plot, you were supposed to be collecting those points, and this is your point. Okay, we are talking about, this is exactly what we were looking for, okay? To realize how accurate is tablets, okay? And whether or not we can use tablets or we can use certain methodologies to estimate agriculture area plots. Okay, this is the objective. Okay, we will plot it afterwards into Quantum GIS, just to show you that we can, okay, take a look on the different, okay, and actually we can, I'm going to see if I can get one of the polygons here. Okay, is the other, oh no, is this? So here, for example, if I open the interview that we have run for the agriculture plot, here we can see the polygon that we have drawn in the tablet. And now as a supervisor, I can check your polygons from the Survey Solution Supervisor app. Okay? And I can say, okay, this is good, or can you please follow better the limits, or, you know? So, and actually I can say, okay, this is IRD, and I can say, these guys enter the wrong EA code, reject, and I say, please modify EA code. The EA code should be 301, okay? Because actually we enter wrongly the EA code. Then I click OK, I reject it, and next time my team synchronize the tablet with the server, I will get a message saying, okay, your interview was not, there was a problem with your interview, with a message. Please change the EA code from 202 to 301. Okay? And while I'm in the field, I can correct that. So this is a little bit the, and if I check, I can check the points here, but well. So this is the magic, no? This is the beauty of Survey Solutions, that I can monitor data in real time. Just a quick review about how Survey Solution works. But let's go to the objective of this training, okay? To compare, well, to work on in QGIS. Okay, all of us, we have the track from the GPX. Am I right? Okay. Do you have these processing toolbooks on your right? Yes? No? Okay, if you don't have these processing toolbooks, it's because of maybe, do you have this processing menu on the menu? Okay, so you go to processing, and if it's not enabled, you won't be able to have that menu on the right of your screens. So now, everyone has processing toolbooks? Yes? If not, you can check as well in plugins, manage install plugins. Processing toolbooks, it's installed in QGIS by default, okay? So you just need to go to installer, to install plugins, type processing, and see and check whether the processing plugin is checked or unchecked. Okay? This is when we lose the processing toolbox, this is the two main reasons. Okay? Now, you see here that we have a searching bar in processing toolbox. This helps us to find tools. Okay? Now we are going to type here lines to polygons. And you will lines, if you type line, you will find a bunch of tools, but the tool we're looking for is called lines to polygons. Did you find it? Lines. So we use this tool to convert our line. Well, actually, it's not even a shapefile; it's a GPX, okay, file. So, but lines to polygon, it's able to read, okay, that line file, even if it's in GPX format. So we select the GPS area, and then we just click Run, and it will be saved as a shapefile in a temporary file. So once we're happy with it, we can save it as a okay. So now what I can do is just to put it in red, because all our GPS inputs are in red. So I'm gonna use like transparent fill and red border to help us to better display the difference between the different polygons, okay? But now it's a polygon, now it's a proper shapefile, okay? Okay. Any? Okay. Yes. Have you found the lines to polygons tool? Okay. So I double click on lines to polygons tool. Then I will select the line layer that came from the GPS, and by default it's gonna be called GPS. I call it GPS areas, and then I just click Run. Okay. Okay. If you have several line files, you can use run as batch process. Okay, and then you just select you can convert in one go several line layers into polygons. Okay. So let's have a look what the data coming from the tablets looks like, okay? So in the, do we, all of you we are all in the same page? Sorry?
No, all of us have the GPX file.
But it's from your, you have to take it from the GPS. Okay, so, yes?
The GPS waypoint that we are trying to download is the point.
We have two types of files. Let me show you. We have in GPX, you will have waypoints, and if at the end of the, when you make the calculate area, when you click finish, okay, it tells you 2,000 square meters, and then it asks you whether or not you want to save the track. No worries if you couldn't save the track. Okay, we have already an example here. Okay, well, imagine that we're gonna think that we have all access to the server, okay, and that we go to the data export section, and since all of you have data in the computer, so we are going to export it into tabular format. Like this, we can open it into Excel and then export it into CSV, okay? So, yes. So this is the process, how it the process in Survey Solution. This is something I have already done. And then we have the what you go to download folder. You open a new Excel book, and then what we're gonna do is to browse and open QGIS Workshop tab. Okay, there's a file in the folder that I shared with you. That it's named. You will find many files there. Oh, shit. So you're gonna find heaps of several files here. You have to open from Excel this file, QGIS Workshop number 2. It's okay? From Excel. So I'm gonna do it in Excel myself. Here, this one. So I'm gonna file, browse, okay, this QGIS Workshop tab. Well, I'm gonna browse. And if you don't find any item, what you have to do is to go here, the type of file, okay, and click on all files. Okay, if not, Excel by default is going to try to find format, XLS format, XLX X format. Okay, so here in that window we click all files, okay, to allow us to see all the files in the folder. Okay, and now we select QGIS Workshop 2, and automatically we have the text import wizard. Okay, we are here. So here you have the steps. We're gonna select delimited, and then we click on next. You tell me when you're there. Okay? Okay. Then we click. We're gonna, because it's a tab file. Okay. So we have to say, okay, the delimiters of that file is tab. Okay. So what it's gonna do is like it's gonna take all the text in between the tabs, and it's gonna put it in the different cells. Okay. It's gonna respect the field structure. And then we click on next, and we should be having the limited next tab, next, general finish, and we should be having our data in columns. Okay. Does it, did it work?
Is it comma delimiter? Sorry?
It's tab delimiter. It's delimited, tab, okay, now is Excel, okay? The stuff we are gonna do now is not GIS, okay? It's Excel. So please pay attention because it's a little bit complicated, okay? It's a bit tricky, would say. So what are we trying to do here? And what I'm trying to Survey Solution export polygons in a very odd way, and this is something that I have wrote down already in order to provide feedback from to the developers. Okay. So. Okay. So I put here in this slide, which is how survey solution share the polygons, okay, and how can we import into QGIS from CSV a polygon. So we have to convert the data or the coordinates from survey solution into WKT language, okay? WKT is well-known text, and it's a system. There's a way to store points, lines, and polygons in a string, okay? So a polygon coordinate into WKT, it will be always like polygon double bracket and then the coordinates of the point 2 separated by a blank space, comma, x2 blank space y2, and I need at least 3 points to define a polygon, okay? But the problem is that survey solution, when you extract the data from the server, as you can see, the coordinates, it just gives you the coordinates of the point, okay? Which is something like this. Well, it gives you longitude and latitude, 1, and they come separated by comma, longitude and latitude, and by semicolon each of the points. So we have to translate into WKT in Excel, okay? We are going to do it manually. What I want you to do is just to do it with, rather than do all of them, that I have already plotted them. So we're going to go to the Excel file, okay? Okay, you have something like this, okay, and there's two types of rows, okay. We have points where we have this building GPS latitude, building GPS longitude. These are when you have selected household location and we have plot the GPS point, we have retrieved this. Say, what I want you to do is like you are going to, well, first let's go to make the point, which is much easier and much straightforward. So I want you to take the GPS lines, okay, and just take the GPS points and put them in a new spreadsheet. So to do this, we can go to Data, Filter, and then we can sort by latitude or by longitude, and then we just copy and paste, okay, into a new spreadsheet. Okay, we only keep the points. Okay, it's okay. You have something like this. Okay, So I just want the rows with GPS latitude and GPS longitude. Okay. So what I do is like I select the first row, and in data menu I click on filter, and then in filter I have this drop down menu, and I select sort smallest to largest. Like this I can sort the data and easily copy and paste. Okay? It's okay? And this is the easiest way. The easiest way, we just save as a CSV. So save as, we call it survey solution household locations, and here in format, instead of using XLS, a format that QGIS cannot read, we're gonna save it as CSV MS-DOS. Do you remember how to import CSV? Import, add the limited text layer, click. He's going to browse what the, so it's called survey solution household location, is there already? The second by the bottom, yes. Click open and click. Awesome. So I'm gonna put, if you can put the household locations into yellow, for example, the ones from survey solution. Remember we had, okay, it's okay, fine. So now we are able to compare, well, the GPS, I only have 2 points to compare, because at the moment that we take this point, our tablet, it was still in cold start. We have experienced it in both GPS and tablet. Our tablet took 10-15 minutes to enable the GPS. So you will see that, for example, but in your map canvas, you are going to be able to compare where the GPS took the fix and where the tablet took the location. Okay, even if we were in the same place, we have kind of discrepancy. Okay, they do not match. For example, in our case, the distance between both points, I've lost my, okay, the distance between both points was almost 6 meters. Okay? So, have you managed to import the point from survey solutions? You see that it's quite easy, it's quite straightforward. No? We just put that on Excel and export into CSV. In this case, it was a little bit complicated because we had at the same time in the same data set polygons and points. But we usually, we had that manipulation. But okay, and now you can see the difference on the location from your team. Okay, the red ones are the points we collect. Sorry, with the GPS. And the yellow ones are the points we collected with the tablets. Now, we're going to do the same. Well, for points, it's clear, no? We haven't done that many times, okay? So now before the tea break, well, we're going to take the data from survey solutions and the polygons, and we are going to convert those coordinates into a comprehensive language for QGIS, and we're going to import them, okay? So let's go back to our Excel file where we had both polygons and points. So, well, first we catch up. Everybody import the points into GIS. Wait, that was good, no? The conclusion, okay? So now, if you can follow me with this, so now we go back to this folder, to this spreadsheet where we have point and polygons, okay? And then we are going to do the other way around. We're gonna get, yes, we're gonna okay, we're gonna go to this plot polygon, and we're going to sort from A to Z. The plot polygon, you will see that we have all these coordinates, okay? I want you to choose only, well, it would be nice, you here, where are the interviewer, originator? It's not here, it's a pity. Well, just to undertake the operation, I want, in order to not to complicate too much, okay? Once you have, well, if you feel strong to convert all of them into WKT, okay? But let's just try one, okay? So what we're going to do is we sort, okay, the data using plot polygon column, okay? We delete this first row because there's no data there, and we are just going to take the first row, okay, one of the polygons with the field, okay? I'm going to show you how to convert manually in Excel from Excel into WKT, okay? So copy, and I open a new Excel spreadsheet. I only have, I'm going to have only one polygon, okay? So I have this, okay? So now I have to, okay, now I have to convert this data format into this. So for the first thing that we're gonna, do you know replace by? Control H. Okay, so if we click in Excel, Control H, you will have final replace. Okay. But we are gonna close first, and we're just going to select the cell. Well, we're going to select the column, okay? Like this, the replace tool is just going to replace in our column. If we don't do this, if we say, okay, replace a comma by a blank space, it's going to do it in all the document. We won't do this only in the plot polygon column. Okay, so now we click Control H, and we are going to replace comma by a blank space. So in find what, you're gonna find please comma, and in the replace with space, I'm gonna just click space. No, semicolon, no, just a blank space. Okay, because I want to remove all those commas. Okay? Blank space. Yeah, it's weird, but it works. Okay? So, and then we click on replace all. And we see, okay, there's 3 replacements. Ooh. It's a triangle. Okay, let's, well, I'll then just do it, and then we are going to make the same, but now we are going to write replace semicolon, the dot with the comma, it's semicolon, by comma. So we remove the blank space and we add comma. And we click again in replace all. So now it has to look like this. Okay? We have the 166 coordinate with a blank space and minus 22 coordinate that is going to be separated with a comma. Does it look like this? So there we have replaced the comma, all the commas by blank space, and then we have replaced all the semicolon by commas. Okay? It's all written by step in the slide. And then in order to, because WKT, they need the first point at in the first position and the same point at the last position to close the polygon. So what we are going to do is to copy the first coordinate and here write comma and paste at the end of the text string. Again, we need to, in WKT, for example, to express a triangle, okay, I need a string with the coordinates of the point 1, point 2, point 3, and again point 1 to allow him to close the polygon. Okay? So what are we going to do is to copy these coordinates and put them again at the end of the text string. Okay? Separated by a comma. So what we do is just to go here, Control copy, and then we add the comma and we paste it. Okay? And just the last step. Are we all there? Then if you want, no? Well, I'm going to finish and then I will catch up, okay? So then the last step is we add the word polygon, double 2 brackets, and then we end the text string with another 2 brackets. Polygon, and then end. Well, this is to show you the process. Then this is something that we can script in Stata easily, for example, or doing an Excel macro, or just with an Excel formula we can do it as well. Okay. But I have to write polygon properly because it's not polygon. Okay. And then save as CSV. I call it test poly. And then if I go to QGIS, browse C, test poly, and then it's already quad geometry polygon, and here we have. Okay? This is the polygons that you have been drawing in the maps in your tablets. Okay? So let's so in my case, what I've done, I did this polygon conversion for all the polygons we extracted from survey solutions. It's this survey solution polygons. Okay? So this is what it looks like. Okay? So we're going to concentrate, so after looking at that and after maybe comparing for example, which team made the triangle? Measure the triangle with a GPS. Huh? Which team made this one with the GPS? Wasn't the team that was attacked by the dog? Was you? Have you imported the GPS trace?
Inside?
Yeah. No, but it's okay. So let's go to this example, okay? It was a big polygon, okay? So in the here in the survey solution data set, in survey solution data set, we have the area that has been calculated with the GPS. In some of the cases, I don't know why you have entered 5, 3, 4. This should have been here in this GPS area in the interview, well, doesn't matter. Well, there was a question that was enter the area that appears in the GPS. Okay, so most of you have entered 443, 5, 152, but here 3, 4, 5. Think that you get confused with the. You got confused with the number of points for the rooster. Maybe yes, 3, 3, 4, 4, 5, 5. Yes, or maybe there's a problem with the way we have imported the data. Which I don't think so. Let's have a look here. Okay, so when we work in tablets, everything is easy, everything is user-friendly, and we tend to forget to read what is written in the questionnaire. Okay, because we start working like robots and we don't read. Okay, so this is a very common error or problem, mistake in when we have people working in tablets. Okay, that they start repeating the same error because they are working like with autopilot. Okay, they have stopped reading what is written in the questionnaire. Okay, so we have the area here. We have two areas. Okay, we can measure the area of this polygon. Because it's not a polygon yet, because it's a CSV. Okay, and we have an area that says that it's 1,500 square meters. And if I'm not wrong, the GPS was measuring 1,800 square meters. It's a 300 meters difference, which is a lot. At the same time, I'm measuring the area of these polygons in a projection where we shouldn't be doing this type of operation. Okay, the 4326 coordinate projection. It's a projection that respects it doesn't distort the shapes, okay, of what we see on the map. That's why they use them for global data sets, satellite images, etc. But it's not very good when we want to calculate areas, and I would say distances. Okay, so we have to be very careful when we say, okay, this land plot that we have measured with the GPS, or we have measured with our GIS tool, makes 2 square kilometers, because we have to need very careful on that. Okay, we have to inform ourselves, choose the right tools, choose the right projection, and maybe it's not our job. It's Lands Department job. Okay, because they have the tools and they have another approach. Okay, for us, so from my point of view, this polygon, draw the polygon tool, it's okay if we want to delineate where the land plot is, but the fact that it's measuring the area, for me, is not okay. It's providing wrong information. Okay. So maybe the pro or the good things from this tool is not that we can measure the area, the surface. It's by far it's not a good tool to do this. Okay, it's not a good approach from the technical point of view. But on the other hand, I find it's quite powerful. The fact that you can show the map to the person that you are interviewing, and he can draw his land plot, or he can locate in the map where his farm is. Okay? Then the area is not our job. Okay? But we couldn't, with GPS units, we were not doing accurate measurement. Okay? It's more, if we want to do a cadastre, we won't ever do a cadastre with this. Okay? We will use another equipment. okay, that deliver better accuracy. And indeed, this is a flat surface, okay? If the land plot is in slope, the distortion, it will be much higher, okay?